Okay, thank you very much. So the first thing I wanted to say was, some of you are new to Software Circus, and there's basically two principles that we founded the Software Circus on. One is that, no, that's not true. Two things that I hate that led to us setting up Software Circus. So one is that normally when you go to a meetup, they talk about one thing, right? So you go to the Cassandra Nederland group, and you talk about Cassandra every fucking week. And that's great if you're 40 hours a week working on Cassandra, but most people are not. And what I really wanted was a meetup where I could hear about all sorts of different things all the time. But there's also another important thing, which is that at these specialized meetups, what you often find is everyone comes and sits down and then doesn't speak to each other and then goes home. So I wanted to create a place where we could encourage more interaction in the community, more people getting to know each other. Now, I don't know how successful we've been in that this evening. I did get you to high five. I was expecting you to do the rest. How's it going? Not very well. Okay, good. We'll keep working on that. So last talk of the night, the one you've all been waiting for, right? Yeah. So I've been around Frank since the beginning of mini-mesos, and it's been really amazing to see this explode on the interwebs recently. I won't say anything more about it. Big round of applause for Frank Scholten, please.
Cool. Okay. Welcome. I'm going to give a talk about mini-mesos in the context of Mantle. Right, so who am I? I'm Frank Scholten. I work at Container Solutions. I'm involved in a couple of open source projects, several mesos frameworks, and the mini-mesos project. This is where you can find me on Twitter, GitHub. Okay, so the outline of this talk will be a couple of things. First, I will talk about Mantle, the project surrounding everything. I will go a little bit into Apache Mesos for those of you who haven't heard about it or like to know more. Then we're going into mini-mesos. I'm going to show you a couple of demos of both mini-mesos and the Elasticsearch framework. But first of all, Mantle. What is Mantle? So the idea behind Mantle is to come up with an end-to-end solution for microservices. It's created by Cisco Cloud, and like the idea is you want to have a microservice architecture. You need a lot of services in place to support this, like service discovery, logging, monitoring, all these kind of things. And what they've done is they added a couple of layers, like provisioning layers, cluster management, and then some supporting infrastructure. And the core of it is mesos and a couple of frameworks. And what we're doing at Container Solutions is we build these frameworks, mini-mesos, like making it really easy to develop frameworks as part of this system. So you can check out the website here for more information. Okay, so mesos, it's one of the core parts of Mantle. So who here actually uses mesos? Couple of people, 3, 4, 5, yeah. Okay. So you can think of mesos as a distributed systems kernel. So in the same way you have a kernel for like a single machine, like Linux, it's a kernel for an entire group of machines. And this allows you to treat this group of machines like a data center as like a single big computer. So you're not programming against a single machine anymore. You have all the resources available, and you can just schedule tasks anywhere. So it runs at a bunch of large companies, Twitter, Airbnb, Siri, and it's getting a lot of traction. And the main reason to use mesos is to improve utilization of your cluster, because let's say you have these 3 different apps, Spark, Hadoop, Rails, but they're utilized at different times of the day. So it could happen that like at one part of the day, one app is just not doing anything because there's no demand, and then you have a bunch of machines that are just sitting there doing nothing. But still you have to pay for them. So Instead, if you move to the right, you pack more services on the same machine, so you have a better utilization. You can shrink your cluster, so you save some money. So let's look now at Mesos itself, like how it works conceptually. In Mesos, you have the idea of a master, and it's sort of it receives like all the resources in the cluster. It can sort of it receives them, and then it can sort of decide what to do. And a resource could be CPU, memory, disk, ports, and in the future in Mesos there will be like more resources will be added. That everything is sort of controllable. So if we move a step further, then we'll see like you have the master, maybe a secondary master, and a bunch of agents. So the cluster, can be really big, like thousands of nodes. And then also there's zookeeper, which is used to coordinate certain things. Like if you want to do master election, leader election, then zookeeper is used to sort of store this data and retrieve it again to determine like who's the leading master now. And it can also be used by other applications. Okay, so that's when you have like an empty Mesos cluster. It's just empty. It's a bunch of resources. But then you want to run some applications on it. You want to run tasks on it, and this is done by a framework. So these three little things on the outside are frameworks, and they sort of define what to do with this resources. So let's say the Mesos master distributes the resources among these three frameworks. Then the next level of scheduling is that the framework can then decide what to do with it. So for example, you can have Elasticsearch running on there. An Elasticsearch framework would then, create a bunch of Elasticsearch nodes, and you might have Logstash or Cassandra or something else, and then you can sort of run all these tasks everywhere. Right, and the other part of it, I'm just showing you the scheduler part. The scheduler part sort of takes resources and schedules tasks, and these tasks are called executors. So in this case, the Elasticsearch framework runs 3 executors, like one on each agent. And also you can sort of, like the executors can talk to the scheduler, so you can make really complex systems this way. And this shows a situation where you have multiple tasks on different agents, like the different colors of the executors. All right, so I explained what Mesos is. I explained frameworks, schedulers, executors. We're building Elasticsearch, Logstash, Kibana, and you can do a lot of awesome things with it, but there's still a couple of challenges when you develop a framework. So one of the things that happens is the feedback loop is it's pretty long. It's when you build your code, you have to create a jar file or maybe a Docker image. You have to upload it to the Mesos cluster across the network. It has to start up, and then in the end you look at the logs and you get like a task lost error. You're like, oh, what's going on? And this whole process, it might take 10 or 15 minutes. So this whole development cycle is really stretched out, opposed to when you have a normal application. You can just F5 and keep coding. So we had to do something about this, right? So another thing is it's very hard to do end-to-end feature testing because you have a scheduler, an executor. There's like code everywhere. You have communication. So if there's a bug somewhere, it can be hard to figure out, what's happening here. So it's hard to do end-to-end testing. There are many components, can be many failures. So we had to come up with something. So we came up with mini-mesos. So the goal behind mini-mesos is to create a developer-friendly framework. So more friendly than doing the whole feedback cycle. So as a way to test your frameworks quicker, and it also has a CLI. So you can check out the website minimesos.org. You can follow us on Twitter, minimesos. I'm going to show you about how it works. So some of the features, it's a containerized Mesos cluster. So if you start it up, It runs the master, the agents, zookeeper. They're all in separate containers. Also, it's written in Java, by the way, and it's integration with JUnit, which means that you can use it in a rule. So you can use add rule annotation, and it will automatically, before the beginning of the test, create it and then destroy it. And also, we have a couple of object-oriented APIs that you can say create a new container, start it, get its IP address. So this is some code you can use with Docker, like make it easy to work with Docker in Java. Okay, so this is a example. Like let's say you have some framework, you clone the Elasticsearch, GitHub repo, you run your test, spins up the cluster. Let's say you have 3 agents here, zookeeper, master, and then when it's up, you can do assertions against it. So you can check, okay, how many tasks are running. Maybe your framework has an API, so you can call the API. You can do your regular JUnit hamclass matchers, and then it's gone and you destroy it. Okay, so now I'm going to give a little demo of system tests for Elasticsearch. Let's see. So I think I'll first show Elasticsearch actually, the whole UI and the framework. So what we did, let me switch to presentation mode. So we created a main class in the source tree, in the system test source tree. And the first couple of lines is like typical mini-mesos. So you say, give me a mesos cluster, give me an image tag. So the tag of the Docker images for the master and the agent. And then you have to give some resources. So in this case, we have, because we have 3 entries in the array, we have 3 agents. And then we build, and then we have a cluster here, right? And then in this line, we say cluster start. And then we have an empty cluster, but then of course we have to start Elasticsearch itself. Now, and we also created a container for it that contains a scheduler. So we started the cluster, we started the Elasticsearch scheduler, they talk to each other, and then we can deploy everything. So let me run it now. Yeah, you can see it starts a scheduler. What it's doing now, it's polling the endpoints on the UI, and you can see first it cannot make a connection, but then it actually can make a connection. It will switch to some other polling. Yeah, so now it's waiting. It already started. It waits until Elasticsearch the ports are actually open, and now it's already there. So we can click on here, and this is the UI. So we have a bunch of graphs. Also, I didn't tell you, we also created another container that puts some data inside Elasticsearch. So it takes the Shakespeare data set from the site and install it. And so you can see there are a bunch of documents in there. It's growing. We have 2 indices because I think I ran it before, so it's now 2 indices. Data set is growing. We have on the left we have some we have a scaling feature. Which is still experimental, so it doesn't take into account replication. So if you scale down, it could just destroy the data. So you gotta be careful. But we're going to improve that soon. This is the task list. So there are 3 tasks running, and I can go to the endpoint, do a search. I get a bunch of documents back from Shakespeare. I can also show you that the nodes can actually see each other. So you have one node, hammer and anvil is one node, and then this is another one, brainchild. Yeah, so it works. All right, so that was the main app. So if you just I know during development we write some code, we run the main app, and we just check if everything works. But now I'm going to show you the system test. So what we have is, for example, the discovery system test. Go to presenter mode again. Yeah. All right. So in Elasticsearch, let's say you deploy 3 nodes. What happens is we use the Zookeeper plugin, so that every node publishes its own information, like IP address and ports and stuff like that, into Zookeeper. And then there's a watch, so the other processes can get a notification saying, "Hey, I registered myself," so they can find each other and form a cluster. And what we do with this discovery system test is to, start the cluster, deploy Elasticsearch, pull the thing until they can all see each other. So we pull all the nodes, and we see if all of them can see all the other ones. So I'll run the test now. Go again, yeah, so it starts polling again. That's it. So in 30 seconds, it creates a cluster, deploys it, checks it, destroys it. So as you can see here on the left, we have like for every major feature we have a system test. So discovery, data, so we can actually retrieve the data. We test around APIs. Like every time we create a major feature, we try to create a system test out of it, and then it works pretty well because sometimes we have like a strange bug somewhere deep in the code, and by creating a system test, you can really check like if I put this in. On the API, I will get this result. And you can test the entire thing. All right. So next thing is another demo. It's the CLI demo. So the mini-mesos CLI. By default, it installs mini-mesos in user local bin. And if you run it. By default, it prints a usage, which you can do. I added this CLI pretty recently, so you only can do up, destroy, and help. So let's do it. I also built in a couple of checks again. So when I do up, I create the containers, and I also pull to see if they're actually up. So it checks the master. If the master state file is available, it also checks Marathon if the endpoint on Marathon is available. And it prints out the IP of the master, so we can copy that. And there we have an empty cluster. And if we're done with it, we can just destroy. I also wanted to show you the Docker internals. So let's try it again. So this is it's like 4 clusters: Marathon, 1 agent, 1 master, 1 zookeeper. And I also make sure that they're all prefixed with mini-mesos in the name, as well as we sort of auto-generate an ID for every one of them, so we can find them back. Currently, you can only run 1 mini-mesos cluster from the command line because it stores a little file in the current dir with the cluster ID, and if you do up, it will check if it's already there. But we're thinking like in the future we're gonna probably do some sort of mini-mesos file where you can just put all the configuration in. You can sort of do up and down, destroy, whatever. And like, let's say you work on a bunch of frameworks, and for every framework you can have your own configuration. That's sort of the idea.
Question.
Mm-hmm.
Because this AP 172 whatever, this one is from Docker containers.
Yeah, because it's in the 172 network.
Right,
So it's a Docker container. Yeah.
So for the users that are using OS X, because Docker doesn't run natively in OS X, you have to run it on a Docker machine.
Mm-hmm.
Would this how do you access this then? Because then this IP, this network will be internal to the virtual machine on which Docker will be running.
Yeah.
So you would not be able to run it from OS. You will not be able to access it from your browser in OS X.
That's true. So if you're running OS X, what you can do is you can add a network route, and then you can directly talk to the containers. But this is interesting because I wanted to show you something else. Thanks for reminding. Use a local bin, because mini-mesos itself also runs in Docker, because the mini-mesos script is just one big Docker command. And we had to pull a couple of tricks to fix it, because we had to pass in the Docker socket so that the mini-mesos container can spawn like a sibling container with the the master and the agent and all this kind of stuff. Yeah, so it's completely Dockerized.
But you guys don't use Docker in Docker.
Yeah, so we used to use Docker in Docker when we started the project, because we thought it would reflect the production environment, because in production you have a Mesos agent with a Docker client. So we thought, well, maybe we should have the Mesos agent in the container, but then also have Docker on that. And even though it worked, there were a few problems with it, because first of all, the inner Docker needed the image from the executor, but then where does it get it from? Because it cannot talk to the host, because it's nested 2 levels deep. So then we created the registry container that you first had to put the image in the registry, and then it gets pulled from there. But that slowed down the build, because for every test you have to push to the registry, right? So we refactored it, so now it's just a flat structure, and the tests are a lot faster. So in Elasticsearch, by default, it doesn't run a system test, but it takes 5 minutes to run like all these tests, which it's pretty good. Okay, let's go back. All right, some internals. So we rely a lot on Docker Java. It sort of implements like all the commands you can do with Docker. And what we did is we created a little wrapper around it to make it more object-oriented. So in mini-mesos, there are classes where you can say new container, start, get IP address, get this, get that, which makes it a bit easier. Whereas Docker Java is more like create a statement, execute, create a statement, execute. We also rely a lot on awaitility, and you can do this. You have this DSL where you can say, wait for a minute and keep on polling, or do a timeout. And we use this all the time for, we create a cluster and we wait until it's ready, and all sorts of asynchronous testing. And also we use jcommander to parse arguments. We use the same code in Elasticsearch. So that's some interesting libraries to use. Yeah, just showing you this. So a couple of features of the framework: Zookeeper discovery. Also, it's resilient, which means if a node fails, it will be immediately started again by the scheduler. It's very configurable. So typically, you would deploy a framework using a JSON file from Marathon, and you could say like, okay, this is the framework. These are all the parameters, but like everything is configurable. CPUs, framework name. You can just pass it in on the command line. You can also run multiple clusters, because you can change the framework name and multiple clusters for different purposes. You can run Docker and jar. So on the build, we create an image for the executor and for the scheduler, but you can also use a plain jar deployment, where the scheduler jar hosts a little server that then exposes the executor, so it will be broadcasted to the cluster. These are like the 2 ways you can deploy it. And we have a UI and an API. So some next things for Elasticsearch is to improve the horizontal scaling stuff. Like I said, the feature currently lives on a branch, and we're working on making it awesome. Another thing is maybe doing snapshots, backup restore, these kind of features. And you know, if you're interested, we hope you also contribute and maybe create a pull request. It would be awesome. So that's it. These are the URLs from GitHub, and we want to thank Cisco for sponsoring the projects. It's been awesome. So thanks. Any questions?
So how does it store the data of Elasticsearch, and when it fails, will it clean up the data again? Because if you respawn in another node, then
Yeah, exactly. So it depends. Depends if you use Docker, it will store it in the volume. However, it doesn't use the persistent volumes feature from Mesos yet, because there were a couple of things. It was sort of it was blocking on a couple of other features that weren't implemented yet. So it doesn't use the persistent volume, because if you have persistent volumes, then you can, for example, say, let's say you have a task that writes some data and it fails. You can sort of tell to Mesos always start it at that agent again, because that's where my data was. And now you could run it into the situation that you started somewhere else on the cluster, and then you have some leftover stuff. So currently it can be improved. Yeah.
But Elasticsearch by default does not store data on disk. That's it.
Yeah, it does. Yeah.
It's
a Lucene index.
For
Sorry?
the snapshots.
Hmm?
For the snapshots, or because as I had it understood, Elasticsearch keeps all the data, all the databases in memory, and only the snapshots is what gets dumped into disk.
No, I think.
Store a lot of data to the disk.
Yeah.
It acknowledges once it's in memory and then stores it disk later.
Yeah.
So because you have many gigabytes of data
Mm-hmm.
in Elasticsearch cluster most of the time, so that's why.
Alex?
You showed how to start the Mesos cluster and the Mesos frontend as well. So what do you do next with it? So if I start it on a laptop and say as I said, Elasticsearch and a couple other frameworks in progress and more finished than the others. So how do I start those and how do I play with it?
Yeah, so one of the features I'm currently working on is the install command. So let's say you have a marathon file with a framework in it. You should be able to do mini-mesos install and then the file, and then you can install it. So it's almost ready, but it will use the internal marathon container to do a curl against it. And that way you can just create a script that says, okay, install this, this, and this, and this, and then you can sort of play with it.
When will it be ready for production?
I don't know. Yeah. I think well.
Will be installed on some production clusters the next
Yeah.
weeks in Cisco, and will be introduced to Cisco clients for production systems, and it will start happening in the next few weeks.
So can you use it for production?
You can use it for production, but
That's
not all feature set is ready. So there are certain functionalities, like you don't really need elastic scaling for production. And also Elastic as a company is being involved now and will help us to certify it and make sure it works right.
Any other questions? Yeah.
You showed us set up with one master and one agent, right? Is that configurable? Like, could I have two masters, 3 slaves, or whatever?
Currently, you can configure the number of agents by adding resource specifications, but we're planning on making everything configurable, right? And then maybe some config file and yeah. All right. Thanks.